Here we're asked to find a polynomial with integer coefficients that has degree 2 and zeros 1 plus I square root of 3 and 1 minus I square root of 3. We know that when a polynomial has a 0 of r, then x minus r has to be a factor. So this time we will have two factors. We'll have x minus 1 plus I square root of 3 and x minus 1 minus I square root of 3. Now, if I distribute the minus signs, I'll have x minus 1 minus I square root 3 and x minus 1 plus I square root 3. Now, this is actually 3 terms times 3 terms. We could do this multiplication directly. We'd get 9 terms and then simplify. But what we usually do is put parentheses around the x minus 1's. Because now we have a case that we have the difference of squares. The first factor is in the form a minus b, the second in the form a plus b, and when those are multiplied, we would get a squared minus b squared. And so in our case, the a squared would be x minus 1 squared, and the b squared would be I square root 3 squared. The x minus 1 squared will give us the trinomial x squared minus 2x plus 1, and the I square root of 3 squared will give us minus 1 times 3, or negative 3. And so this simplifies as x squared minus 2x plus 1 plus 3, or plus 4. And you should confirm that if you use the quadratic formula, you will get the two given zeros. The next example, we're to find a polynomial with integer coefficients which has degree 3 and zeros 0 and I. This time we have to use the conjugate zeros theorem to understand that if I is a 0, the opposite of I also has to be a 0, because imaginary numbers appear as zeros in conjugate pairs. So our factors will be x minus 0, x minus I, and x minus negative I, which is x plus I. So we have x times, here we have the difference of squares, x minus I and x plus I, so a squared minus b squared would be x squared minus I squared, which is x times x squared minus a negative 1, which is plus 1. So we'd have x cubed plus x. Both of the coefficients 1 there. And our last example, degree 3 again, and zeros negative 4 and 1 plus I, and by the conjugate zeros theorem, we also would have a 1 minus I. So our factors would be x minus negative 4, which is x plus 4, and x minus 1 plus I, and x minus 1 minus I. As we did in the first part of the video, I'm going to write this as x minus 1 minus I times x minus 1 plus I, and have the difference of squares, which we can do more easily than multiplying 3 terms by 3 terms. And so now we have x minus 1 squared minus I squared. That's going to be x plus 4 times x squared minus 2x plus 1 minus a negative 1, so plus another 1. So it'll be x plus 4 times x squared minus 2x plus 2. But now we have to distribute the x and the 4 over the x squared minus 2x plus 2. So we get x cubed minus 2x squared plus 2x plus 4x squared minus 8x plus 8, which simplifies to give us x cubed plus 2x squared minus 6x plus 8. And I invite you to start with the polynomials and then reverse the steps and find the zeros in order to check your answers.